Okay, Wildcat, today we're on the journal page 1, Solving Systems of Linear and Quadratic Equations, Part 1. Steps to solve systems of linear and quadratic equations by graphing. Step 1, graph the linear equation. Linear graphs include standard form and slope-intercept form. Standard form is ax plus by equals c, where slope equals m, which equals negative a divided by b. X equals c divided by a is the x-intercept, y equals c divided by b is the y-intercept. Slope-intercept form is y equals mx plus b, where m equals slope and b is a y-intercept. If x equals a number, it's a vertical line. If y equals a number, it's a horizontal line. Step 2, graph the quadratic equation. Quadratic graphs include standard form and vertex form. Standard form, ax squared plus bx plus c equals y. Where the vertex is h equals negative b divided by 2a, and k equals a times h squared plus b times h plus c. Where the y-intercept is 0, c. Vertex form, y equals a parentheses x minus h squared plus k. Where the vertex is h, k, and the y-intercept is 0, a parentheses 0 minus h squared plus k. Okay, solving systems of linear equations, part 1. Step 3. Identify the points of intersection. One point of intersection is one solution. 2 points of intersection is two solutions. And no points of intersection is no solution. Let's take a look at example number 1. Okay, solve the given linear quadratic system graphically. Okay, the first thing we do is graph x plus 1 squared plus 2. Okay, so we're going to go to Desmos and we're going to graph that. So we're going to do parentheses x plus 1 squared plus 2. Okay, now I want to find the vertex first. So that's negative 1, 2. Okay. Okay, so we have negative 1, 2. Now we need 2 points to the left, 2 points to the right. Okay, so I can click here. And now sometimes the point doesn't click, but this point is equal distance to this point. So we would see that here and here. So then when that point doesn't, we know that, okay, this is negative 1, 2. This is 0, 3. So we go to the right 1, up 3. So this would be 1, negative 1, I'm sorry, negative 2, 3. So I can actually graph that point. Negative 2, 3. Okay, so we have a point to the left and right, and we can graph. Okay, so let's go ahead and graph those 3 points. Okay, so we have negative 2, 3, and then 0, 3. Okay, so let's go ahead and do that. So negative 2, 1, 2, 3, negative 1, 2, and 0, 3. Okay, so we have a parabola. Okay, and that's our first equation in yellow. Okay, and then y equals 2, let's go ahead and graph in purple. And that's a horizontal line at 2. Okay, so the point of intersection is negative 1, 2, which is your solution. All right, go ahead and finish up example number 1. All right, let's take a look at example number 2. Okay, so again, we need to start by graphing the first equation. So we're going to go to Desmos. And we're going to graph x squared plus 2x minus 3. All right, so we first want to find the vertex. So that's -1, -4. Now we need at least a point to the right and point to the left. So we have 0, 3. Now this point doesn't want to click, but we know that these are equal distance. So 0, 3, so this is 1 unit. So we go 1 unit this way. So we go 1 down. So this is -2, -1, 2, 3. So we can verify that. So that's -2, comma, -3. And you can see that point matches up. We also can see we have this point here, 1, 0, and -3, 0. So we have our points. So we have the point -3, 0, -2, -3. And then we have -1, -4. We already have 0, -3. And then 1, 0. Okay, so now let's graph those points. Okay, so -3, 0, 1, 2, 3, -2, -3, -1, -4, 0, -3, and 1, 0. I'm going to go ahead and graph that in yellow. Now, to graph y equals, this number in front of x is slope, so that's your m value, which is -1 divided by 1. And then your b value, which equals -3. So let's graph that point first, 0, -3. This tells us we go down 1 to the right one, 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 right one, down 1 to the right one, down 1 to the right one. But this is equivalent to, say, 1 divided by -1. So we can actually go up 1 to the left one, 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 so on. Now our solutions are the points of intersection. So -3, 0, and 0, -3. All right, go ahead and finish up example 2. All right, let's take a look at example 3. So again, we need to graph this first parabola using Desmos. So we have negative parentheses x minus 4 squared plus 2. Now, we need a vertex first, and then we need a point to left and to right. Now, these points don't look like they're good points, okay? So let's see if we can find another point that is good. All right, so we're just going to have to approximate our points. Then I guess just use those. So we for sure have, oh, forgot it, 4, 2. So 4, 2, okay. And then we have, let's round that to 2.6, 0, and 5, that rounds to 5.4, comma 0. Okay, so 4, 2 is easy. 1, 2, 3, 4, up 2. Okay, now 2.6, that's between 2 and 3. So that's this point right here, just approximate. And 5.4, 1, 2, 3, 4, 5. 5.4 is between 5 and 6, so There's our points, okay? Now let's go ahead and graph that in yellow. Okay. Now, for here, our slope is -6 divided by 5. And our y-intercept is 0, 9. So let's graph that first. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this tells us we go down 6 to the right 5. So down 1, 2, 3, 4, 5, 6 to the right 1, 2, 3, 4, 5. And then we go down 1, 2, 3, 4, 5, 6 to the right 1, 2, 3, 4, 5. And then we draw a line. You can see here that they do not intersect. So there is no solution. Okay, go ahead and finish up example 3 and start working on an assignment and have a wonderful Wildcat day.